3.2, building linear functions from data. So this is our first look at scatter plots. You did cover scatter plots a little bit in maybe Math 2 and Math 3. So it just kind of depends on what your teacher was able to cover during that time. But you're going to see them really briefly here. And after that, you're really not going to see them much again until you get to college. So I just have a few examples here of what a linear and a nonlinear scatter plot might look like. And you can see you're going to have a quiz question from that on your next quiz. So number 10 is going to be, if I give you a graph, can you determine if it's linear or nonlinear? So the ones that are linear, all of the points are forming close to a line. There's really not much of a curve to them. The nonlinears have a very distinct curve to them. Like here I can draw a line through it. Here I can draw a line. Oh, look, curve. Oh, it's curving. Oh, it's curving. So that's, very simple with scatter plots. This is going to be a very quick video. Plotting the points, that's the longest part when you guys are going through this. So to draw a scatter diagram, I have, hold on, let me change the size of my graph paper. That sucks. Small. Okay, that one fits. So I have my graph here. It's already made. I just went by ones. A lot of times it's easier, especially when I look at my numbers for X and Y. They're not super large. So I'm just going to go with it. So to draw a scatter diagram, you're just plotting the points. So 3, 4. I should have left these. 4, 6. Are these going to make a line? Not necessarily. So don't force them to make a line. Okay, they don't have a constant slope here. Almost done. You guys can be graphing yours too right now, so you don't have to wait to do it in class. Okay, so there's my scatter plot, which is pretty linear. That's pretty good. Now it says select 2 points and find the equation of the line. When selecting your 2 points, you're going to use the first and the last point. So I am going to use 3, 4 and 9, 16. So to find the equation of this line, first I have to find the slope. So my change in X, I'm going to be lazy and I'm not going to plug into the equation. So here I'm adding 6, and my change in Y, I'm adding 12, 12. Whoa. So I'm adding 12 on the Y, I'm adding 6 on the X. And you guys can do that straight from your table. So I could even come over here and say, from 4 to 16, I'm adding 12. From 3 to 9, I'm adding 6. Just don't forget your slope is delta Y over delta X. It's my change in Y over the change in X, which is 12 over 6, which is 2. And I get the same thing here, 12 over 6, which is 2. So there's my slope. Once I have my slope, now I'm going to pick a point, and what we did back in Chapter 1 and Chapter 2, you are going to use the point slope form. So if I know my slope is 2, I'm going to use the point 3, 4 just because it's smallest. So y minus 4 equals 2 times x minus 3. You guys better remember this. That's why I'm not really going over it. So I distribute and I get 2x minus 6. Add the 4. And y equals 2x minus 2. So there's my equation. Then when it says graph the line on your diagram, you just get a straight edge, use your ID card. It's really easy, and you are connecting the first and the last points. That's all you have to do. I'm going to go down here because I know that that's where my y-intercept would be at -2. And I'm going to cheat again. And I'm going to draw my line so that it goes through the first and the last and my y-intercept. So that's your very first look at what a scatter plot is. It's just a set of data. You plot the points. You can use the first and the last to find the slope. And then finish your equation by picking a point and plugging into point slope form, and then moving it into slope intercept. All right, example 2. So I have this one drawn a lot for you already. Let me make this a little bit larger for while I'm talking about it. So here, I didn't start with 1 on my x-axis, or sorry, my y-axis. I jumped all the way to 64. I noticed that my smallest number on the x-axis is a 64. And then it only goes to 76. So that I can go by ones. So you see this little swiggly, if I were to really zoom that in, it looks like this, little swiggly, and then there's the rest of my graph. It's showing that I cut off part of my graph. That's what it's showing. So it's okay for you guys to not start from 1. You just have to show that break. So now I'm going 64 all the way to 76. And then my humidity, my x-axis, was by 10. So I just kept my x-axis by 10s. And then I plotted the points. So pause, go ahead, plot the points if you haven't done that yet. Now when it says find the line that fits the data, don't forget you are using the first and the last points. So my first point is 0, 64. My last point is 176. So I'm going from 0 to 100. So I'm adding 100. I'm going from 64 to 76. So I am adding 12. So my slope, change in y over change in x. So 12 over 100. And I can divide by 2. And actually I can divide by, I'm going to cheat, I'm going to get my calculator. I don't need my calculator. I can divide by 4, and I get 3 over 25. So now I'm going to use the point slope form, and I'm going to use the 0, 64, just because there's a 0 there. So y minus 64 equals 3 over 25 times x minus 0. Well, that 0 you can ignore, and then I'm going to add 64. So y equals 3 over 25x plus 64. So please do not panic. Oh my gosh, my slope's a fraction. I'm not going to be able to do this. Don't panic. If you use the correct point, the one that has the 0, you're not even distributing the fraction. You only have to multiply it to the x. And that should be super easy for you guys. Should not be a big deal. Now when you're interpreting the slope, your slope is 3 over 25. Well, y is the temperature. X is the humidity. This is my temp. This is my humidity. So to interpret this, it's a sentence. As the temperature increases by 3, the humidity also increases, though it is by 25%. So for every 3 degrees increase in temperature, the humidity is going to increase 25%. So now if there's questions, make sure you're writing them down. Now in D, predict the temperature with 65% humidity. There's 2 ways you can do this. 1, you can use your equation. So y equals, and then since x is humidity, y is temperature. So I went back and I saw that in my table. X is humidity, y is temperature. Predict the temperature when you have 65% humidity. So then I'd plug in 65 for my x. And then it's plus 64. So that is really simple. You plug in, you do the math, 3 times 65, divide by 25, and then add 64. Or you can use your graph. You can go over to 65 and then go up and try and find that point that's going to be somewhere here, so it kind of fits with everything else. So here's where that extra point falls, and then I go over and my temperature is about 72 something. So either way you guys want to go through and do this, if I were to use my calculator, 3 times 65 divided by 25, and then I'm going to add 64, I get 71.8 degrees. So using the graph, not as accurate. The graph is going to be more accurate than your equation, because the equation just uses the first and the last points and it ignores everything else in the middle. But your graph, at least you're using everything else in the middle. So if I use my graph, I'm going to get about 72.5 degrees. I'm not going to mark you wrong on your quiz as long as you're close, but you have to show me how you got the answer. You have to show it using the graph, or you have to show it using your equation. So that'll be completely up to you how you're going to want to do that. Okay, the last two, domain. Don't forget, domain are the x values. So I'm going to look here. Now, my domain is the x, which is humidity. And since it's in percent, since it's a percent can only go from 0 to 100. In reality, it's 0 to 100%. So my domain is from 0 to 100. And I am going to use brackets because I'm not going to skip over humidities. I'm going to hit every single humidity that's in between 0 and 100. So I can include everything. It's not just going 10, 20, 30, 40. There's no jumps. It continuously flows. And then is it a function? If I look here, do I see any repeated x values? No, I do not see any repeated x values. So for a function, x cannot repeat. Since no x repeats, yes, it is a function. All right, that wraps up 3.2 on scatter plots. Hopefully this will help you so you're ready for your classwork tomorrow. See you with any questions.